Hello everyone, my name is Shambhavi. Hope you all are doing well. So we were basically solving out this particular question in which we had some things regarding the topic. Just let me go above first of all. Yeah. So we were just solving out the question regarding out the matched or the paired sample, right? This was a topic that we were dealing with. So in that we added two columns, before and after, and we just made out a new column that was differences by like subtracting after from the before, right? Then these were the data which we had got out for performing out the test. So we had just founded the sample mean, the standard deviation. Then we put on that let mu d be the population mean. For the differences we use the subscript d to denote differences. Okay, x bar d was basically the main difference of the sensory measurements, right? H naught, that is basically my null hypothesis. That was mu d is greater than equal to 0, right? And another H naught I was having that mu d is less than 0. After that we were having the distribution for the test. Right, so these were some things which we were having here. We just founded n minus 1, that is 8 minus 1 is equal to 7. So n, what we had taken out, n was the total count of these before values, like these values total count which I was having, right? So we were having in total 4 plus 4, these 8 values, right? So this is only the n for us. So hope you just got out first of all this much thing which we have discussed into the previous video. Now let's proceed on. Basically I hope that you had even solved out the things onto your own. So if you have done that, you can just clarify it, like tell it from here. Okay, right, that is actually okay. Distribution is done. So after calculating out, okay, now it's the turn for calculating out the p-value using the student t distribution. P-value using the student t distribution. Distribution. Right, so we just needed to calculate out the p-value using the student's t distribution. So in that case, the final p-value that would be coming as an answer for you would be 0.0095. Okay, 0.0095. This is the final p-value which will be coming for you from the student t distribution thing. Fine. Now I'm just not going to find out this p-value for you. You can just do this thing onto your own. You are that much now capable of finding out the things for yourself, right? Okay. Now what I'll be just doing here is that I will be making out the graph for this particular thing, for this particular topic. So let me just go above and put out a line here, and the graph would be a normal distribution only. As you all know that we will be making out a normal distribution graph only. So it would be somewhat the bell shaped. So let me just make out that particular. Yeah, hope this is actually okay. I know it's not that much fine, but yeah, you can consider this thing as a graph. Okay, fine. So here, this particular portion is, let's say, minus 3.13. And here comes the, what is this minus 3.13? You just have a look that this is basically my sample mean for the differences which we had founded out, right? So that has been plotted out. So for this minus 3.3, we just even figured out the p-value. So the p-value which we founded out was 0.0095. That I had put on you to find out the p-value for this particular thing. Right? In between it's 0. Onto the other side, that is x bar d, and here we could just write out that from h naught mu d is greater than equal to 0, right? And I could just highlight out this another part which we are having right here. So let me just put on some, okay, just 1 second, where's that highlighter? So yes, here's the highlighter. I could just highlight out this particular part which we are actually having out, right? So yeah, that thing is actually done right here. So that was completed. Let me now just come down. After this, what we were supposed to, do out the random variable for the differences and all those things we were supposed to write out, right? So yeah, here I could just write x bar d. X bar d is the, random variable, random variable for the differences, So x bar d is the random variable for the differences. Now, after this basically comes out the sample mean and the sample deviation. We had already figured that out. So we'll just write that here. the sample mean and sample the sample mean and the sample standard deviation, the sample mean and the sample standard deviation of the difference of the differences are what we have here. We have x bar d is equal to minus 3.13, right? And we have s bar d that is equal to 2.91. So this, the first one is basically the mean, and the second one is the standard deviation. We have already find this thing above only. We are just writing out the things right here. Okay. Now, after this comes, when we just figure out all the things, we will be comparing out the p-value and the alpha. So comparing alpha and the p-value. So for alpha, what we were having, alpha, where's that? Yes. So we would just need to find it out, a test at a 5% significance level, right? We need to figure out this thing. So alpha would be now my 0.05, right? And what about the p-value? So my p-value would be actually 0.0095 that we had figured out. So in this case now, what's the thing? That alpha is greater than the p-value. Right, this is the case which is actually applied out here, that the value for the alpha is greater than the value for the p-value. So we could just make out a decision. I could just write here, make a decision. Okay, we can just make out a decision that whenever we have this case, that whenever let me write out that thing. So whenever alpha is greater than the p-value, okay, whenever this is the case that alpha is greater than the p-value, so in that case we just reject out the h naught. This means that mu d is less than 0, and there is improvement, and there is improve. Okay, that is and there is okay, just let me remove this out. Improvement, right? So whenever this is the case, and actually we need to make out a decision when alpha is greater than p-value, so we just reject out the h naught, and this means that the mu d is less than 0 and there is some improvement. So what conclusion I could actually make out? So conclusion can be that at a 5% level of significance from the sample data, there is sufficient evidence to conclude that the sensory measurements on average are lower than hypnotism, right? Hypnotism appears to be effective in reducing pain. You got that? I just figured out this conclusion in a different way. What were the conclusions we were giving from the last two topics? That was different, right? And now here I just put on some different conclusion. Let's write that down. So I could just say that at a 5% level of significance, okay, let me calm down. At a 5% level of significance, yes, from the sample data, there is sufficient evidence. Till now, remember that into the previous questions we were writing that there was insufficient evidence to conclude out anything, right? But here we are writing that yes, we have a sufficient evidence. Now why is that so? Because here we are rejecting out the h naught. So it means that alpha is greater than the p-values. In that case, we reject the h naught. So there, in that case, we could just make out a proper conclusion for a particular thing. If this is not the case, then again we had written out that there is insufficient evidence and all those things. But yeah, that's not the case right here, correct? So I would just write that there is sufficient evidence to conclude that the sensory measurements on average are on average are lower than, let me come down, on average are lower than hypnotism. Right, so hypnotism appears to be effective in reducing out the pain. Right, so this was what we just needed to find it out. We just needed to find the things onto the 5% significance level. Are the sensory measurements on average lower after hypnotism? Test at a 5% significance level. So we had tested out, and yes, that was thing that hypnotism appears to be effective in reducing out the pain. Right, so this was how we just solved out this particular question. This question was belonging to the matched or the pair samples, right? So in that case, we were having already two columns, after and before. We just figured out the third column, that was the difference, that is the subtraction of after and the before. After that, we were having the data for the test, that like basically that was the differences data which we had find out. This differences one, okay, that we had taken out. After that, we founded the standard deviation, the sample mean. Then we put out a weight, like mu d, that was the population mean for the differences. And then we put out several conditions. We founded the DF, that is distribution for the test, that came as 7. After that, we figured out the p-value, we made out the graph, and we just figured out the sample mean and sample standard deviation, that was okay. Then we compared out the alpha and the p-value. So as soon as we compared out the alpha and the p-value, we found it that the value for alpha is greater than the p-value. So in that case, we were able to make out a clear decision that whenever the value for alpha is greater than p-value, we reject the h naught. So it means that mu d would be less than 0, and there is improvement. So I could just make out a final conclusion that at a 5% level of significance from the sample data, there is sufficient evidence to conclude that the sensory measurements on average are lower than hypnotism. So this hypnotism can appear to be effective in reducing out the pain. Right, so hope you just got out this particular way, that how we just figured out the questions for these particular topics. And here we just completed out one another topic for the statistics for data science. From the next video, we'll be starting out a new and a fresh topic. Right, so this is all for this video. Till then, thank you and take care.